In this project, we're going to learn about exponential functions, how they work, and what are the elements and what did they mean, and also what's exponential decay, and a few applications of both formulas, and which basically are the same formula. And we are also going to explain a few of the implications of using nuclear energy and what happened in Chernobyl, and mention briefly about nuclear energy here in Mexico, and explain how nuclear energy is safe or can be safe, and what do we think about it.
Exponential growth is the rate at which a certain value grows exponentially over time. These kinds of graphs look very different from a linear graph because we can see how they do not have a direct or definite slope, and as the exponent starts getting bigger, the line continues to go up. These graphs are commonly used to measure world population or radioactive decay. The formula that commonly simulates these kinds of graphs is A equals P. These values represent this. P is the original amount, E is the natural logarithm, R is the annual rate, and T is the years invested, and A is the actual amount or the amount that you want to get with the formula.
In exponential functions, the domain is always all real numbers, the range is from 0 to infinite, the horizontal asymptote is y equals 0, and the reference point is 0, 1. And in exponential decay, the domain is from negative infinite to positive infinite, meaning all real numbers, the range is from 0 to infinite, and the horizontal asymptote is y equals 0, and the reference point is 0, 1. While both of these functions are exactly the same, the difference is that in exponential functions, the intervals are always rising, and in exponential decay functions, they're always decreasing. In exponential decay from the left quadrant to the right, and in exponential functions they're also from left to right, but they're increasing, and here from left to right but decreasing.
Well, in exponential growth, to get a line that goes up from quadrant 2 to quadrant 1, we have that the rate is positive. But in exponential decay, we have that the rate is negative, meaning that it decreases exponentially. It's this equation right here. So it's how a value decreases related to time. And it's commonly used for measuring radioactive decay because scientists use half-lives, which is a measure of how elements start losing its properties, and it can be calculated, for example, to know the ages of dinosaur bones or of ancient rocks that were found. So it's a very commonly used formula, and yes.
Exponential functions can be used in many different ways. Some examples are when the population of a country, city, or population of an animal is increasing. You could know how much the population has increased year by year by the growth rate. Another example is on the interest rates of a bank. When people want to get money from the bank, you can tell the bank to lend you money, but you will owe them a bit more of what you asked for. Interest rates may vary depending on how the economy of a country is. The sale of smartphones can also be an example of exponential functions. When smartphones first went out on the market, people started to buy more and more over the years. You can apply the exponential functions to see how much the sale of smartphones has been changed over the years.
The April 1986 disaster at the Chernobyl nuclear power plant in Ukraine was a product of a flooded Soviet reactor design coupled with serious mistakes made by the plant operators. It was a direct consequence of Cold War isolation and the resulting lack of any safety culture. The resulting steam explosion and fires releases at least 5% of the radioactive reactor core into the atmosphere and downwind. Two Chernobyl plant workers died on the night of the accident, and further 28 people died within a few weeks as a result of acute radiating poisoning. UNSCEAR says that apart from increased thyroid cancers, there is no evidence of a major public health impact attributable to radiation exposure 20 years after the accident. Resettlement of areas from which people were relocated is ongoing. In 2011, Chernobyl was officially declared a tourist attraction.
Nuclear energy is a kind of energy that do not generate a lot of pollution because the waste it produces, a lot of them are just like water vapors, and that do not pollute the environment as much as factories or other kind of energy. Using nuclear energy can cause several implications, like environment impact because the transportation of nuclear fuel from one plant to another is pollution hazard. And the fuel, once it's used, you can just throw it away because it's very dangerous and radioactive. Also, by using nuclear energy, we generate a lot of wastes, and almost all of these wastes transmit radioactivity. Is it nuclear energy clean energy? Spinning fuel has the potential to be hazardous, but as long as the reactors are operating correctly, with no breaches or leaks, there are no directly harmful to the environment. Fortunately, breaches in nuclear cores are already rare, and from technology upgrades to modernized reactors units, things are getting even better. Like if I have an industry that use nuclear energy, I will make like a safe protocol that makes safer this to not generate an accident like Chernobyl accident where the machine just explode and liberates all the radioactivity. And maybe a very good thing to do is in Laguna Verde, that it's a nuclear plant here in Mexico.
Okay. How did we feel working like this? This project was actually not that hard as the other projects because what we explained is a very recent topic and it's actually discussed in the news a lot with Donald Trump and everything. And the exponential growth and the exponential decay formulas are actually pretty easy. So we feel like it was an easy project and we did like it.
And also it was very fun to get to know other people from other campus because we did it with other campus obviously, and but also it was very hard because we all have different schedules and sometimes it gets difficult to work all at the same time, and yeah, but we like it. Yes.
In my personal opinion, I found this project very interesting and different since it was a new experience to work with people from another campus, meet people that we didn't knew, and make them our friends. But also I found this a bit difficult since our schedule was different. One day they were busy and we were free, and the other day we were busy and they were free, so our schedules didn't match, but at the end of the day we made this project and it was great.